Our goal in this chapter is to find local extrema. In this video, we'll recall some old definitions and then we'll state the first derivative test. So as far as old definitions go, I do mean old all the way back in the very first section of this class. We defined what it means for f of x to be increasing and decreasing. F of x is increasing on an interval if for every pair of values x1 and x2 in the interval, if x1 is less than x2, then f of x1 is less than f of x2. I should say, though, that for being a standard definition that appears in every calculus textbook, there's surprisingly a fair amount of disagreement about this. Other textbooks would make that second inequality non-strict. And what our textbook simply calls increasing, they would call strictly increasing. And decreasing functions are defined in a parallel way. A function is decreasing on an interval if x1 being less than x2 means that f of x1 is greater than f of x2. And same disclaimer as before. What we call decreasing, some resources would call strictly decreasing. And we introduced these definitions before we'd done any calculus calculus. So it's finally time to relate this material to the calculus that makes this course up. So here's an example of an increasing function. And here are some tangent lines. And note that these tangent lines all have positive slope. Here's a decreasing function. Here are some tangent lines. These tangent lines both have negative slope. That is not a coincidence. We can state this as a theorem. Suppose that f of x is differentiable on an interval. If f prime of x is greater than 0 on that interval, f of x is increasing, and if f prime of x is less than 0 on an interval, f of x is decreasing. Now, just because f of x is differentiable on an interval doesn't mean that it's always positive or always negative. Maybe sometimes it's positive and the function is increasing. Other times it's negative and the function is decreasing. What happens when the derivative goes from being positive to being negative, or from being negative to being positive? Well, I know I said up front that I'd define the first derivative test, which addresses that question in this video. But on second thought, it probably warrants a video of its own.